So you are going to do 7.3, which is trig integrals, and I'm going to get a little tricky with it today. So here's your essential questions if you want to look through those. And you can see it probably looks like Chinese right now, but even Fang will be able to do this. Okay, so as we're going, it's going to be helpful to remember to all of these formulas. So you've seen them all. You should know them. These two we haven't used as much, but those are true, I promise. So just kind of get those. So this is going to help us when we have integrals that look something like this. So you can see like maybe you have a sine squared x, maybe you have a cosine cubed x going on. So it's just that M&N means that there are powers. So our goal as we're doing this is to pull out a cosine x and get all the rest of that junk to be sines. Or pull out a sine x and get all the rest of the junk to be cosines. So that's our goal of what we want to try to do. So let's look at this first one. And here I see, like, if I tried to pull out a cosine, so if I left it as sine cubed x, cosine cubed x, and then I pulled out one cosine x dx, this would be, when I did my u sub, that's what I would try to want to get to be my du. Don't write this down. Sorry, I should have said that. So this is what I'm trying to get to be my du, which means all the rest have to be equal to sines. Well, that cosine cubed is really horrible because I have something, if I had cosine squared, that I could plug in, or even if I had cosine to the fourth, I could do cosine squared times cosine squared, but a cube is bad. So as we're doing these, when we decide which one to pull out, we want to pull one out so that the rest is evens going on. So here when I pulled out a cosine, the rest left were odds, so that didn't help us. Okay, so that's bad. So what if I went the other direction and I pulled out one of the sines? So I'd have a sine squared left and a cosine to the fourth left. So I pulled out one of the sines. So all I've done is rewrite this problem where I'm trying to get this to be my du. So if that's what's going to be my du, then the rest needs to be in cosine. So I've got to get that sine squared to be in cosine. Okay, so I know that sine squared x is going to be equal to 1 minus cosine squared x. So I'm going to use that substitution. So now I'm going to have the integral, and then I have 1 minus cosine squared x times the cosine to the fourth times that sine x dx. And again, I'm thinking I'm going to leave that out there for that du. And this guy went right there. Okay, so my u is going to be the cosine. And the derivative of that is going to be the negative sine x dx. I can put that negative over here. So I have this negative 1 minus u squared now, u to the fourth, and then the rest of that part is du. So that negative du was that x sine x dx. And now this isn't too bad. So I can distribute. I'm going to distribute my u to the fourth and my negative all in one swoop. So that's going to be u to the sixth minus u to the fourth du, which becomes u to the seventh over 7 minus u to the fifth over 5 plus c. Substitute cosine to the 7th over 7 minus cosine to the 5th over 5 plus c. What? Good job. So again, just to kind of recap, since I could take out a sign and the rest of the signs were even, then I could make a good substitution. Now, just to kind of think about, if I had a sine cubed x and a cosine cubed x, I could technically pull out either a sine or a cosine, and either one of those would be left with evens. So when they're both odd, you get your pick of what you want to pull out. But if only one of them are going to be odd, then that's the guy you got to pull out. Okay? All right, so let's go to the next one. Yay, I got some bounds. Okay, so I'm going to leave those bounds off while I'm doing all the nitty-gritty, and then I'll get them plugged back in. So let's think about what this looks like. If I just rearrange, so that's cosine cubed x and sine to the 1/2 x, sorry, negative 1/2 x dx. And again, I'm just leaving the bounds off for now. So what's the odd that I have to pull out? The cosine. So I'm going to take one of those cosines out. To put with the dx. So it's an equivalent statement. All I've done is take that cosine out, because the rest of the cosines I can write in terms of sine. Oh my gosh, I just blanked, so that's 1 minus sine squared. Okay, long day. And I'm going to go ahead and get my bounds back now because I'm going to be making my u sub. So I want to make sure that I also change my bounds as I do my u sub. So my u is going to be the sine. The du is that cosine, which we had hoped it would be. Yay! Change your bounds. So let's see, u of pi over 6. So sine of pi over 6, let's do our rule. Here's my pi over 6. So sine is going to be root 1 over 2, which is 1/2. And then u of pi over 3. So again, sine of pi over 3 right here is radical 3 over 2. So let's go change that up. So I have 1/2 to radical 3/2. I have 1 minus u squared, u to the negative 1/2 du. Let's go ahead and distribute so that we can do our power rule. Okay, so my power rule, I'm going to add 1 and divide by the new power. Add 1, divide by the new power. And now I evaluate from 1/2 to radical 3/2. That looks disgusting. Let's see how gross it becomes. So that becomes 2 times radical 3/2 to the 1/2 minus 2/5 times radical 3/2 to the 5/2. So there's that first part. Minus 2 times 1/2 to the 1/2 minus 2/5 1/2 to the 5/2. And power to you if you want to simplify that. I'm not. Okay, so now what happens if I only have cosines or I only have sines is I am going to have to go back again to these formulas, and I'm going to have to use these. So this is when I only have cosines or only have sines. So we're going to use those two formulas. Okay, so on this one right here, this cosine to the fourth, I'm going to rewrite it as the cosine squared times the cosine squared and write that formula twice. I'm going to take out that 1/4 as a coefficient because that's annoying. And then I'm going to foiled your plan. I'm going to FOIL the numerators now. And then again, we have a squared. So I'm going to have to use the formula that we did up here again, but be careful because now your inside is already a 2x. So when we double it, like we did on that last one, it's going to be a little bit different. So can you go ahead and do that step? Okay, so when I double the inside, it becomes 4x, but my formula, I only keep it over 2. Don't think you have to do a 4 there as well. That's not what the formula said. If you remember, you double the inside and divide by 2. All right, so I'm just going to rewrite this a little bit. I can put the 1 and the 1/2 together. And then I have that 1/2 cosine of 4x. So now there's like really no use sub unless you still are struggling with the inside of the cosines or sine. So I can go ahead and take that antiderivative. So I have the 1/4 antiderivative cosine. 2 goes along for the ride. I have the sine, and then I divide by that derivative, which would be 2. And then let's just rewrite that. Distribute my 1/4 and all that other fun stuff. 4, 4, 16, 32. And there's your beautiful answer. Good job. Oh, wait, there's more. So now we're going to do some trickies with secants and tans. So again, here are the formulas that we should know. Oh, remember that one from your quiz? Okay, so these guys we should know. Here again, we have that, oh my gosh, identity with the squares is called something, I can't remember right now. Pythagorean identity, the P guy. Okay, so then now as I think what I can pull out, I'm thinking the derivatives of what give me secant x tan x or secant squared x. So if I can get everything in secants here, then the derivative of du is going to be that secant x tan x. If I can get everything in tan here, so that's my u, then the du is going to end up being that secant squared. So that's the goal, if I can take out a secant squared or secant x tan x.